Now let's discuss how we can make use of the space that we have on the stack that is controllable by us. And let's also discuss how we can make use of this control on EIP register. A simple idea here is that we will place some shellcode here, and then we will force this EIP register to execute the shellcode that we are placing here. Before getting into that, what is shellcode? Let's quickly go back to our slides and discuss what shellcode is. Shellcode is basically a sequence of instructions that your machine can execute directly. You don't have to worry about compiling shellcode because shellcode is something that can be understood and executed by the CPU directly. So in the space that we have on the stack, we can place some shellcode because it can be directly executed by the CPU. That's the idea. But how do we get this shellcode? There are multiple ways. We can use online resources, or we can use a tool called MSF Venom, which comes pre-installed with Kali Linux, or we can write our own shellcode. Now in this course, we are going to learn how to write our own shellcode, but let's first finish this exploit by using some shellcode that's taken from the internet. Now there are multiple resources available online where shellcode is publicly available. Shellstorm.org is one example, and exploitdb.com is another place where you can get shellcode. Now, we will have to be extremely careful when downloading shellcode from publicly available resources because the shellcode that you are downloading can have malicious functionality and you may execute it on your machine, and when you execute it on your machine, it can cause damage if it is built by someone with malicious intent. This is where I suggest you to write your own shellcode for the exploits that you're writing. But don't worry about it. We are going to discuss how to write in the coming videos. But just for the sake of completing this exploit as soon as possible, let's take some shellcode that's available online. So let's switch back to our virtual machine. And I'm going to take this shellcode from PacketStorm Security. Now, if you look at this, this is execv, which is basically executing /bin/sh. Now, execv is a program that executes the binary that is provided to it. Now, in this case, bin/sh is provided, and then execv basically executes bin/sh and pops out a shell. Now, this is the shellcode we are going to use for this exploit. So let's copy this here. And let's quit this and let's copy this exploit 3 and let's call it exploit4.py, and let me open exploit 4 and let's quickly place shellcode somewhere here. You can place it anywhere you want. It's just going to be a variable in this case. Okay, so the shellcode is now placed in your exploit. Now, where do you place this shellcode in your buffer? Let me once again go back to my slides and quickly show you the plan. If you see this, this is where the beginning of our buffer is. We have 268 A's until here, and then 4 B's here. So somewhere in between these 268 A's, we are going to place our shellcode. And I'm going to replace the beginning of the buffer with something called a nope sled instead of A's. Nope stands for no operation. It basically does nothing but just passing the execution to the next instruction. Now the reason we are going to use this nope sled here is when we control the EIP and when we pass the execution to this nope sled, basically does nothing but sliding the execution towards the shellcode, and at some point of time the execution will land on the shellcode and our shellcode gets executed. So that's the whole idea. Now what we are going to do is we will place the shellcode somewhere here by putting some nope sled in the beginning, followed by the shellcode, and we will place some padding here to fill in the 268 characters. After that, we will deal with this EIP. So for now, let's fix this part. We will place knob sled, we will place shellcode, and we will fill in the remaining with some padding. Let's switch back to our virtual machine. And let me just go with some 60 knobs. So I'm going to replace this junk with knob sled. And a knob is represented with /x90. So essentially I'm using 60 knobs, right? Followed by, we are going to use the shellcode. So let's first go back to this print and print the knob sled, followed by shellcode. And then we have 4 B's, which is still the junk. Let's simply rename this as EIP. Let's remove this plus. So let's add this here. So followed by EIP. And as usual, we have a bunch of C's here. So let's just remove this here and let's place it here. Okay, now one last thing that we are missing here is the padding. Let's quickly move here after knob sled and let's call it padding. And this padding can be simply anything. Let's say A's. How many A's? Should be 268 minus 60 knobs minus the length of the shellcode. So the remaining should be this padding. So basically we are still going with 268 characters before overwriting EIP. So let's now fill in this print. So let's add padding here and this looks nice. Now let's save this file and let's quickly generate a payload 4, and let's quickly check if everything is as expected on the stack. So we are going to run gdb referral and let's put a breakpoint. Let me first check the one function and let's put a breakpoint here. I'm just clearing the screen so that you will be able to clearly see this. I'm putting a breakpoint at the address that we have just copied, and let's run this using cat. I guess it is exploit. I guess it is payload 5. Let's check it. Okay, there is no such file or directory, so it should be payload 4. Let's hit enter and the breakpoint is hit. That's fine, that's expected. Now let's quickly analyze what we have on our stack. Look at this ESP. It's currently pointing to BBBB, which is the top of the stack. And once the ret instruction gets executed, this BBBB will be popped to EIP. Right, so let's quickly check the stack. ESP minus 268 like we did earlier. And look at that. We have some knobs followed by shellcode, hopefully. Let's quickly go ahead and check if it is the shellcode. So we can do that by opening up a new terminal. And let's quickly check exploit4.py. And if you see, the shellcode is beginning with 31 db/b3. So let's check 31 db/b3 after the knob sled. And let's see the ending. This is E3CD80. You can see this E3CD80. So the shellcode is completely placed. I'm checking this because I'm just making sure that the shellcode is placed from the beginning until the end. right? So now we have confirmed that the shellcode is placed onto the stack, and after that we have filled in the remaining characters with some padding, followed by our BB. The key takeaway from this video is that we managed to identify a place where we can place the shellcode, and we have grabbed some shellcode from the internet, and then we placed that shellcode onto the stack. In the next video, we are going to discuss how to use this value in the EIP to redirect the control onto the shellcode. That's all for this video. See you in the next one.